This is an interesting question. There are two blocks which are placed on an inclined plane, and the plane is having a rough surface whose coefficient of friction is given. So here mu is 0.25, and the mass is given. Capital M is given, that is 10 kg. Small m we need to find, and the capital N is moving downward with an acceleration that is 2 meter per second square. So let's see what are the forces are acting on the capital M. It's a kind of known problem. Like when we have a inclined plane of angle theta, we keep a mass m here, then certain forces will act on it. One is the gravitational force, which is directly downward, mg, and the normal force, which is kind of perpendicular to that plane. If we take the component of this mg, then in this way, mg sine theta will act, and opposite to normal force, mg cos theta will act. So here, the normal force is going to be mg cos theta. So these are kind of initial things which we need to know. So the same thing I'm going to apply here. For this capital M, if we see, uh, capital Mg will act downward. Not capital Mg, it's Mg sine 53. Will act in this way. Since it is connected with the rho, so the tension will act. Since the mass is moving downward, so the frictional force will act opposite direction, that is upward. Let it be F1. So if we write the equation for this capital M, Newton's second law for capital M, then we have mg sine 53 degree minus tension minus frictional force 1, which is equal to capital M times A. Since here sine 53 is there, so this is a kind of special triangle. If we have a triangle, right angle triangle, whose sides are like 3, 4, and 5, the angles are going to be 37 and 53. So this will be 53, this is going to be 37 degree. So with this we can write all the sine cos thetas. So let me just write it because we will need it. So sine 53 is equal to opposite by hypotenuse 4 by 5. Cos 53 is equal to 3 by 5. Sine 37 equal to 3 by 5. And cos 37 equal to 4 by 5. Just based on this triangle we can write it. So yeah, this you should remember because some problem they will give in this special case. Okay, so we can figure out tension if we substitute rest of the things. So I'll keep tension one side, rest of the things other side. Mg sine 53 minus F. Okay, F also we can expand it. So mu times N, frictional force can be written as mu times N, normal force. Normal force in this case it is mg cos 53. Cos 53 degree and minus m times a. So let's substitute everything. M is 10, G is 10, sine 53, 4 by 5, minus mu is 0.25, M is 10, G is 10, cos 53, 3 by 5, minus M is 10, A is 2. So if we divide, we'll get 80, and here 260, 15, and this is 20. So we'll get 45 Newton. So tension we figure out that is 45 Newton. Fine. Now we need to figure out the small m. For that again we'll put this one. This is going to be mg sine 37 degree and tension is in this way. and the block is going to move upward because capital M is moving downward, so small m should move upward. And frictional force will act in the direction which is opposite to the direction of movement. So F2 will act in this way. We'll write an equation for small m also. I'll use other color for small m. So tension is acting upward. Mg sine 37 is downward minus frictional force is downward, which is equal to m times A. Yeah, tension and two forces are downward and acceleration is tension direction. So this is how it will look like. And we'll substitute the things. This is 45 minus mg sine 37 minus, again, mu times n we will write. Here n is normal force, mg cos 37 degree equal to ma. So let's bring the mass terms into one side. So we will have 45 equal to mg sine 37 it's not minus, it's plus mu mg cos 37 plus ma. So we'll take m outside and remaining things g sine 37 plus mu g cos 37 sorry, plus a, which is equal to 45. So 45 equal to m into g sine 37. How much? 3 by 5. Mu is 0.25 into 10 cos 37. 4 by 5. Plus acceleration is 2. So m into this is 6 plus 2 8, yeah, 2 plus 2, which is equal to 10m. 45 Newton equal to 10m, which means the mass is going to be 45 by 10, which is 4.5 kg. So the mass of the small one is 45 kg.